Hi friends, it's Kamal and you are watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, I will explain functions. Okay, it's a new topic and it's just a continuation with the others, quadratic equation or linear equations I have covered in my previous videos. So that will be helpful if you just watch that before we proceed with the functions. So the function is a relation that uniquely defines outputs based on inputs. Okay, so let me explain to you. So let's presume you have any inputs. So let's say you have any x input, and then presume this is a box. So this is a function. Okay, so you can say this is a function. And in this function, any number you put in the x, that will double it. Okay, so what will be the outcome then? So this is input, and that will be the output. Okay, so whatever the x value is, so what we say is function of x. What will be the function of x? That here it says, let's say it says any number that will be squared. Okay, and then it will be the output. Let me explain to you again in other method. Let's say, so what input you has done here, one input, so every input has exactly one output. So in other words, what do you really have here? You have a relation which is the connection between the two numbers, or you can say two variables. Okay, so you can also say variables. Okay, so let's say you have dollar and the pound, so they have a connection between these two currencies, and you're planning to, let's say you're planning to travel United Kingdom and you have a dollars. So you can say the dollar. Okay, before I start this, let's say $1 is approximately 0.6 is pound. Okay, let's presume. Okay, I really don't know the exchange rate, but let's say this is what it is. So this is a relation between these two currencies, or the two numbers, you can say. Yeah, so I can say if I write how many dollars I need in order to get pounds, so I can say dollar here, and then the function of, so dollars are the function of pound. So the D, this is how I write D, the function of dollar, function of pound. Okay, same as we put down here, function of x. Usually we write like this, the function of x. So the function of dollar, yeah, function of dollar. So it is a D pound sign is equal to dollar multiplied by whatever the exchange rate is. So this is what it will give us. So in other words, what is that? So the function is a mathematical relationship that maps each values of a set inputs to a single output. Yeah, and usually it's denoted by, the notation is fx, which is function of x. So please don't get confused with if you say that is function is multiplying with x. It's not the case. When you write like this, this is a function of x, and it's used to represent the function of x. So this is what we say. So whenever we will say function of x, we will write in this way. Okay, so that's the notation. So let's say the set of possible input for of function. Okay, so let me just make the set of possible inputs. So you have here so let's say you have here 3. Okay, and this is where we're saying the set of possible input for the function is called domain. So the input value that you will say domain. Okay, and the output you will get range. Okay, clear? So in this diagram, if I say the function of x is equal to x square, okay, so the function of x square, fx equal to x square, that will map the value of the domain to the value in its range. So what will happen? So if the value here is 3, yeah, so we will say what is the value of 3? X is 3. Okay, so that will be, because it's x square, it will multiply by 3. So 3 multiplied 3 is gives you 9, right? So the range here, that would be 9. Yeah, so that is what your output is. So you can see the relation between these two numbers. Okay, the set of possible output of the function is called range, as I already have explained, right? And I will also explain to you the roots of the function or the values of the x for which fx equal to 0. So we will talk about this later on. So let's say I give you another number. Let's say you have 7. So the function of x, which is your 7, yeah, that is equal to 49. Yeah, so the range will be 49. Same here. If you have, let's say you have a -7, so the function of -7, that will also be 49 because it's a square. Yeah, so that is also 49, right? And let's say if you have 1/4, so the function of x, which is 1/4, that will give us 1/16. Okay, so that will be your range, 1/16. Clear so far? So you see the function, again going back to the this statement here, the function is a relation that uniquely defines outputs based on inputs. So whatever your inputs would be, that will uniquely define your output. Like in this case, your function of x is equal to x square. So any input you will have, that will be square. So that the square, whatever the value of the x would be, that will be square, and that will give you output in the form of range, right? Let's move on to the example now. So let's say the function f and g are given. So I write down here the function functions f and g are given by function of x, fx, sometimes people we call fx as well, 2x minus 10. Okay, so now you see the function of x, yeah, the input, that will be the input now. See, it has changed now. Yeah, so that is fx, and then also and it says and gx. So the function here is now g, because we have to we have to write two notation. One is fx, one is gx. That is equal to x square minus 9. Okay, so this is your gx and this is your fx. Okay, so two different now. And this is here, it says x is sign like e, but it's not e. I explained to you what is that. And this is r. So this is we call the symbol, like you say e here, is actually is a member of. So whenever we say x is the member of, the symbol r represent the real number. So if I write like this, I will say x is the member of real numbers. Got it? So I write down here. So the symbol e means here is a member of. Okay, so you will say member of. Okay, member of, and the symbol r that's represent the real number. Okay, so this is real number, real numbers. Got it? So if you see this, you know exactly what I'm writing. So what it says then it says the find the value of the, so we need to find the values of f5. So you see the x is 5 now, and for function g is 10. Okay, so it's pretty simple because you have done equations and other quadratic equations, other equations. You have solved that, you have simplified in my previous videos. So all you need to do is insert the value or substitute the value. Okay, so we say here f5. Okay, that will be, you go here, yeah. So this is your equation. So if I write down here fx, what was that? Fx equal to 2x minus 10. Okay, so it's 5 here. Okay, minus 10. So you see it's 10 and 10, that will give us 0. So here to find f5 function of where x is 5, so we substituted x equal to 5 into the fx. Okay, so I just write down here what we have done here. Substitute x equal to 5 into the function fx. Got it? Okay, and the same we will do here for g as well, which is 10. So the function of, so you see the function of gx here is x squared and minus 9. Okay, so this is what it is. So because it's 10, that will be the 10 square minus 9, and that will give us 100 minus 9 equal to 91. Okay, then you got it. So this is okay. Then it's also asked that find the value of x for which. So it's also asked with this, it says find the value of x for which fx is equal to gx. Okay, so now he's saying that these will be two functions are equal. What is fx here? 2x minus 10. That is equal to, what is your gx here? That is your gx, x squared minus 9. Right? So you just need to simplify this, okay? And as I have covered in my lots of videos, these things, so I'm pretty sure that you're okay with that. Okay. Okay, you can just change sign as well, whichever you want to do simplify. I just simplify straight away for you. I'm sure you can do this, right? And that will give us, yeah, and the x would be equal to 1. Okay, so we have to find the value of x for which fx is equal to gx. So we found the value which is x equal to 1. Okay, so I'm pretty sure with this simplification of the equation, right, we can do it. Okay, let's move into the another example. So here we will say that function f, so again the function f is defined as function of x that is equal to x squared plus 6x minus 5, where x is the member of real numbers. Remember I explained to you this one here. Symbol E means is a member of, and the symbol R is the real number. So it's a member of real number. Okay. Okay, here what they're asking you, they say write fx in the form x plus p square plus q. Okay, so this is actually I have covered in my previous video. Okay, in quadratic equations. So as I said, please watch that before watch functions. Before go with the function, then I will really recommend that you watch the previous videos as well. So let's say you have fx equal to x squared plus 6x minus 5. Yeah. So what I have these forms just explained to you. This kind of form we call complete the square. Okay. So we call this complete the square for x squared plus 6x, and then you simplify. Okay, so completing the square, which you must watch in my previous videos, and then you just simplify the expression, right? Simplify the expression. Okay, so completing the square for this, that would be right. So these things here, that will be under completing the square in my previous video. And then you got here. Okay. So here we got fx, write fx in the form of, whenever you all see this kind of form, you know this is a completing the square form. Okay. Okay, then that was the one. You can say A. Let's say B. It says hence or otherwise find the roots of fx. So let's say find the roots of fx. So finds the root of fx. Remember I said to find the roots, you do fx equal to 0. Okay. So what we have here, your fx, you have here x plus 3 whole square minus 14. That will be equal to 0. Okay. Got x plus 3 square equal to 14. Yeah. And then you got here x plus 3 equal to plus minus square root of 14. So what we have done, both sides square root. Okay. So this is what you got. Okay. So square root of that just cancels out your this. So if I put, let's say, what I have done here, and I do in red so that you know. Okay, this is I've done. So that's cancel out your square with the square root to solve this equation. Yeah, but however, you need to write here plus minus because this could be any, both number, plus and minus as well, right? So x plus 3, I already have given you that. Okay, I'll write up one more time, clear for you. Okay, and then your x be equal to minus 3 plus minus square root of 14. Okay, so you see the fx has two roots. So you can write here fx has two roots. One is minus 3 plus square root of 14 and minus 3 and minus square root of 14. Right? Good. Let's get another examples as well. Okay. So in this example, okay, it's asking you to find the roots of the function. So this you can have in the exam as well. I will carry a good marks. So it's asking you to find the roots of the function fx equal to x to the power 6 plus 7x to the power 3 minus 8, where x is the member of real number. Okay, right? So how we will do this one? So you see here the fx can be written as a function of a function. So what that mean actually? So there's a slight trick in there. Function of a function, which means that the only powers of the x in fx, yeah, you see here, power of the x in fx are 6 and 3, and obviously 0 here. So you can write in quadratic function of x3. Okay, so I explained to you what exactly mean that. So let's say if I write down here your equation here, so what we have to do here, fx equal to 0. Okay, so your this equation that will be plus 7x, that will be equal to 0. Okay, so here the fx can be written as function of the function. Okay, the only power of x in fx is you have this 6, 3 and the 0. Okay, so let's presume you treat x3, if I say to you, you treat f3 as a single variable. Okay, so if I say this is a single variable, so you treat this as a single variable. Okay, and then you factorize. Okay, got it? So how would you do this? Okay, so it can be technical. I will also explain to you other method, so alternative method as well, whichever you want to do in exam. That's entirely up to you, but I will explain to you both methods. Okay, so remember, now you need to concentrate on these two actually, where thinking as x to the power 3 as a single variable. Okay, right? So you see this can be written as like this. Okay, right? Now here is a single variable now. So you won't say, oh, it's x3. So okay, you can, I will explain to you when we do the alternative one. We will just say this x3, that can be like u. So then you will see if you have here like say x3 is z. So if I say z square plus 7z minus 8, so that actually made your quadratic equation. And that will be really easy for you to factorize that as well. Yeah. Now again, the product and the sum you need to do, as you have been doing this a lot of time. So you know that we got here 8. Okay, so that is multiply with 1, that will give us minus 8, and then 8 minus 1, that will give us 7. Okay, so let's do this one here. So write this again. So the 1 you can write down like this. Remember, this x3 is a single variable. Yeah. Okay. Okay. So whichever you want to write down, you can write minus x, which is a 1, minus 1 here, so which is x, and x3 is a single variable. Right. So then I would like to write this for you so that you don't get confused. You can write this like x to the power 3, you can write twice, because x to the power 3 is twice, yeah, and it's also single variable. Minus x to the power 3 plus 8 x to the power 3 minus 8 equal to 0. Okay, then you can do this. Okay, so you see these terms are exactly the same, so you know somehow you're doing okay, and the factorization is correct. Then you just need to write okay. So this is where then you can say your x to the power 3, 8 is equal to 0, and x to the power 3 minus 1 is equal to 0. Okay, and I'm sure you can do the rest. So the roots of fx here, okay, I can probably write here. So roots of the fx here is 2 roots, yeah. So that is 1 and minus 2. So I'll just write down here for you. It's the roots of fx are 1 and minus 2. Okay, so this is one method you can do. Okay, however, if you find difficulty by solving this way, because you can easily get confused with x to the power 3 to just think as a single variable. So you can, what you can also do, you can say, all right, this is the alternative as well. You can say, let u or z or whatever you want to say, let's say u is equal to x to the power 3. Okay, so, and then you can say, what is your fx here? So this is the equation here. Okay, I just got this from here. Now, if you say that, what we'll do, you will replace any x3 with u. Okay, so you will see that will give you quite a good picture when you try to solve this. So let's say what you will get here. Okay, so replacing x3 with u will give you u square plus 7u minus 8. You got it? So this is what you got now, u square plus 7u minus 8. Okay, so some of you say, well, this is pretty simple. Yes, it is, but depending on examiner, they might ask you to solve in this manner, by this method. Or if they say any method, then you can probably solve in this method. So by doing this, okay, you will get here, I write down this here for you, u square plus 7u minus 8. Yeah, and that will give you u minus 1 and u plus 8. Okay, now when you factorize, you will see this is what you will get, right? So same thing here, fx equal to, then you can say fx, that is here, that is equal to 0. Okay, because this is how you find the roots, right? So then you can say your u minus 1 equal to 0, and you got here u plus 8 equal to 0. Then this means the u equal to 1 and u equal to your minus 8. Okay, so this is what you got. Now, however, that's not the your final answer, because you have up here, up there, you said let u equal to x cube. So basically, this is the value for the u, but in real terms, that's not really your answer. So what you really need to do, you need to again replace that u with x3, right? You got it? So replacing this with x3, that will give you x to the power 3. Okay, so this is what you got, right? Okay, you must do this, otherwise you will lose marking. Okay, if you leave with just with the u. So this is what it will give you, right? So x to the power 3 is equal to 1, and then x to the power 3 is equal to minus 8, right? So that will just simply give you here 1, and here it will give you minus 2. Okay, so you see your answer here, 1 and minus 2, exactly the same as here. So again, the roots of fx is 1, x equal to 1, and you got here x equal to minus 2, exactly the same. So this is more or less. I will also cover in my future videos functions in details. For today, this is more or less. I hope you like this video, and I'm pretty much sure that I made a clear understanding of what exactly functions is. Okay. Now, do me a favor, if you are finding this video very informative, like and subscribe this video. Okay, and be sure to click like button, drop a comments if you have any question, and then I will do my best to reply. Thank you.